Hello, and welcome to Applications of Systems of Linear Equations. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and assistant professor at Doña Ana Community College. Alright, so Applications of Systems of Linear Equations. Example 1. You manage an ice cream factory that makes 3 flavors: creamy vanilla, continental mocha, and succulent strawberry. Into each batch of creamy vanilla go 2 eggs, 1 cup of milk, 2 cups of cream. Into each batch of continental mocha goes 1 egg, 1 cup of milk, and 2 cups of cream. While into each batch of succulent strawberry, 1 egg, 2 cups of milk, and 1 cup of cream. And we're going to assume there are other ingredients as well, but we only care about the eggs, milk, and cream right now. You have 350 eggs, 350 cups of milk, and 400 cups of cream. What we want to know is how many batches of each flavor should you make in order to use up all of your ingredients. It's a good idea to read through the entire problem. Don't think about it too hard in the first reading. Just take it in, see what's going on. Oh, I see the repetition of eggs, milk, and cream, eggs, milk, and cream. I have 3 different flavors of ice cream. Okay, what's it actually asking me? How many batches of each flavor should you make? Okay, so we focus on our question or the action statement to help us figure out how to label our variables. Let's let X be the number of batches of creamy vanilla. Let's let Y be the number of batches of continental mocha, and Z be the number of batches of succulent strawberry, right? How many batches of each flavor? So each flavor, the number of batches, will be our variables. Looking back a sentence, we have 350 eggs, 350 cups of milk, and 400 cups of cream. We have totals for eggs, milk, and cream, so we know that those will be our equations. So the question or action statement tells you how to label the variables. In this case, our totals were going to tell us what types of equations we have. So let's break it all down. Looking at eggs. In creamy vanilla, we have 2 eggs. So that's 2 times X. Continental mocha has 1 egg, so 1 Y. And succulent strawberry has 1 egg, so that's 1 Z, for a total of 350 eggs. Moving on to milk. 1 cup of milk for creamy vanilla. 1 cup of milk for continental mocha. And 2 cups of milk for succulent strawberry, with a total of 350 cups of milk. Finally, creamy vanilla has 2 cups of cream, continental mocha has 2 cups of cream, and succulent strawberry has 1 cup of cream, for a total of 400 cups of cream. All right, so the question or action statement is going to give us how to label our variables. Once we know our variables stand for the vanilla, the mocha, and the strawberry, we look at the totals, and that'll tell us what each equation stands for. I'll have an equation for a total number of eggs, total amount of milk, and total cups of cream that we're going to use. Now that we have the equations set up, we can solve them. So if we use eggs and milk, looking at eggs and milk, we can eliminate the X value. Let's multiply milk by negative 2. Negative 2x, negative 2y, negative 4z, negative 700. We're going to add that to our egg equation. 2x minus 2x, they cancel out. Y minus 2y is a negative y. Z minus 4z is a negative 3z, equal sign. And 350 minus 700 is a negative 350. Alright, let's also use eggs and cream. Notice how they have the same coefficient 2 in front of x. Let's multiply the egg equation by a negative 1. So I'll have a negative 2x minus y minus z equals a negative 350. Add that to my cream equation. The x's cancel out. Negative y plus 2y is y. Negative z plus z cancels out. And negative 350 plus 400 equals 50, which tells us right away that y is 50. We'll have 50 batches of continental mocha. It's nice when an answer pops out this quickly in the problem. It doesn't always happen that way. I was expecting an equation in both y and z, similar to this one, but we got an answer instead. Since we know we have 50 batches of continental mocha, and we had this last equation, negative y minus 3z equals a negative 350, I could put my y value in as 50, and have negative 50 minus 3z equals a negative 350. Add 50 to both sides. Negative 3z equals a negative 300. Divide by negative 3, I get z equals 100, and we'll have 100 batches of succulent strawberry. The only thing left to find, using our eggs, milk, and cream equations, variables identified, we know 50 batches of continental mocha. We found z equals 100 batches of succulent strawberry. Using the milk equation, x plus y plus 2z equals 350, where y is 50, z is 100. So 100 times 2 is 200, plus 50 gives me 250. X plus 250 equals 350, so x equals 100. Wrapping that all up, we should make 100 batches of creamy vanilla, 50 batches of continental mocha, and 100 batches of succulent strawberry, using these ingredients and making sure nothing goes to waste. Moving on to the next example. This time you own a hamburger franchise instead of ice cream. I'm always a big fan of doing the hamburger first and then ice cream, but whatever, we'll do the hamburger second. You're planning on shutting down operations for the day, but you're left with 13 buns, 19 defrosted beef patties, and 15 open slices of cheese. Notice these are totals. These are total amounts of ingredients that we have. Rather than throw them out, you decide to use them to make burgers that will sell at a discount. Plain burgers require 1 beef patty and 1 bun. Double cheeseburgers require 2 beef patties, 1 bun, and 2 slices of cheese. And regular cheeseburgers require 1 beef patty, 1 bun, and 1 slice of cheese. Let's head to the question. The question is going to tell us how to label our variables. How many of each type of burger should you make? How many of each type of burger? Alright, so let's let X be the number of plain burgers, Y be the number of double cheeseburgers, and Z be the number of regular cheeseburgers. Since I know how my variables are labeled, I can go back to my totals. I'm going to have an equation for buns, an equation for beef patties, and an equation for cheese slices. Here we go. Ignoring everything that doesn't actually help us here, we find that the beef patties, there are 19 of them. Plain burgers require 1 beef patty. Double cheeseburgers require 2. Regular cheeseburgers require 1, and I have 19 total to use. In terms of buns, each type of burger has only 1 bun, and I have 13 total buns. So I know I'm going to have 13 total items to sell, right? These burgers. Cheese. My plain burger doesn't have any cheese on it at all, so I don't include an X. My double cheeseburger has 2 slices of cheese, and my regular cheeseburger has 1 slice of cheese, for a total of 15 open slices of cheese. Now we can solve the equations. Using equations 1 and 2, beef and buns, notice the only difference, right? They both have 1 X, they both have 1 Z. The difference here is a difference of 1 Y. This 1 Y extra that beef has gave us 6 extra on the right hand side of the constant term. So we know Y equals 6. And that's all the work we have to do. Think about it. Once we know that Y equals 6 double cheeseburgers, we can go to our cheese equation. 2 times 6 is 12. Subtract 12 from both sides. If 1Z equals 3, right, 2 times 6 is 12 plus Z equals 15, so Z equals 3 regular cheeseburgers. Now I know we're going to have 6 double cheeseburgers. We're going to have 3 regular cheeseburgers. That's a total of 9 burgers already used up with the 13 buns that we have total. So we must have 4 plain burgers, no cheese. That's a shout out to you lactose intolerant people. At least put ketchup on it or something. Okay, so you don't always have to do the, quote, work in order to solve these systems of equations. Sometimes you can do the comparison and it'll give you an answer just as easily as the step-by-step math will do. The Fancy French Perfume Company. This is an example that's slightly different. It doesn't necessarily have totals in everything we're looking at. There's a relationship equation. So here we go. The fancy French perfume company recently had its secret formula divulged. It turned out that it was using, as the three ingredients, rose oil, oil of fermented prunes, and alcohol. Moreover, each 22-ounce econo-sized bottle contained 4 more ounces of alcohol than oil of fermented prunes, while the amount of alcohol was equal to the combined volume of the other 2 ingredients. How much of each ingredient did it use in the econo-sized bottle? Remember, all of this here in black type, that's the blah blah blah. Let's not focus on that. Focus on the question or action statement. How much of each ingredient did it use? Let's let X be the number of ounces of rose oil, Y be the number of ounces of oil of fermented prunes, and Z be the number of ounces of alcohol. Now we'll go back and see what we can get from the rest of the problem to help us out with these X, Y, and Z designations. Alright. First of all, there was a 22-ounce econo-sized bottle. If you're buying perfume 22 ounces at a time, it's not fancy, and it's probably not French. So, 22 ounces altogether. Remember, X is the number of ounces of rose oil, Y is the number of ounces, Z is the number of ounces, so I have a total for ounces. The total number of ounces is 22, so X plus Y plus Z has to be 22. Alright, there's one equation down, we just got to get 2 more. This econo-sized bottle contained 4 more ounces of alcohol than oil of fermented prunes. 4 more ounces of alcohol. So it already had more alcohol, Z, than the oil of fermented prunes, Y. So in order to make them equal, since Z was already more, to make them equal, we add the 4 to the Y. Right? Add 4 to the number of ounces of oil of fermented prunes, and you'll get the total for the number of ounces of alcohol. Last phrase here. The amount of alcohol was equal to the combined volume of the other 2 ingredients. So alcohol, Z, was equal to the combined volume of the 2 other ingredients. So Z is equal to X plus Y. Some of you might see a way that you can use substitution in order to solve this from here. Go right ahead. If you don't see substitution necessarily, I haven't taught that method in class. Here's what I would do instead. Now that I have my X plus Y plus Z equals 22, I'm going to keep that equation. But remember, in systems of equations, we always line things up. So I'm going to get all the variables on the left side of the equal sign and leave this constant 4 on the right. So I'm going to subtract Y from both sides. I'll have negative Y plus Z equals 4. And here, I can subtract X and subtract Y from both sides, leaving a 0 on the right-hand side. Negative X, negative Y plus Z equals 0. System of 3 equations and 3 variables. Solve it. Give it a shot. Hit pause. No, really, go ahead. Hit pause. But you knew I was going to solve it with you, so here we go. I want to keep this X. I'm going to eliminate all the X's below it. So I'm going to add equation 1 and equation 3, since the X's already have the same coefficient of 1, but opposite signs, a positive 1 and a negative 1. When I add the 2 equations, X and negative X cancel out. Would you look at that? Y and negative Y also cancel out. And I'll get 2Z's equal 22. If 2Z equals 22, then Z equals 11. 11 ounces of alcohol in this econo-sized bottle. But I know Z equals 11, and I'm looking at equation 2 here. When Z is 11, negative Y plus 11 equals 4. Subtract 11 from both sides. I'll get negative Y equals negative 7. And dividing both sides by negative 1, I'll get Y equals 7. So I know Y equals 7, I know Z equals 11, and I know this has to add up to 22 total ounces. So, where am I here? 22. Subtract off the 11, subtract off the 7, that leaves 4 ounces of rose oil, the part that smells good, 7 ounces of oil of fermented prunes, and 11 ounces of alcohol in this perfume bottle. Like I said, If you're buying a 22-ounce econo-sized bottle, it is not fancy, and it is most likely not French. But we can still solve the equations anyway. That's it for applications in solving systems of equations. Focus on the question or the answer statement in order to label your variables. Then go back and look for totals or relations to know what type of equations to set up. Once it's all set up, you have the skills, you can definitely solve these. That's it for now. Thanks for listening.